Today, I am honored to introduce our speaker today, David Poston, the Chief Operating Officer of the Allen Institute for Brain Science. David joined the Allen Institute in 2011 to help build the business plan for the 10-year plan announced on March 2012. I left my glasses down on the table. During his tenure at the Allen Institute, he has helped drive expansionist initiatives to build the infrastructure to support the organization's and scientific objectives. But prior to the Allen Institute, he's held several important jobs in finance and leadership in a few small operations you might have heard of. They include Corixa, Honeywell, Todd Shipyards, and the Rocket Research Company. Now imagine, this guy's a brain scientist and a rocket scientist. Pretty smart. I think the average IQ in this room just doubled. David is originally from Yakima, and he received a BA in Business Administration from the University of Puget Sound, where he graduated with the Norton Clapp Arete Scholarship. Close enough? David also serves as a board member for the Plymouth Housing Group and Washington Biotechnology and Biomedical Association. Won't you welcome, please, to our podium, David Poston.
Thank you. Thanks for your interest in the Allen Institute. I'm really happy to be here today on behalf of 300 of us in Fremont, Washington. As we consider the smallest building blocks of the brain, from genes, chromosomes, cells, neurons, synapses, the hippocampus, which is the location of learning and memory, and into our Brain Explorer tool and our reference atlas, with dots that mark gene expression and gene activity, coronal and horizontal views, we can easily forget that despite hundreds of years of research, little is known about how our brains work. Not to mention how to treat those who suffer from brain disease. According to the NIH, 25% of us, 25%, will suffer from some form of brain disease during the course of their lives. And 25% of that population will suffer a debilitating form of that disease. To truly help on this front, we need to build a foundation of understanding how the brain works. Paul Allen founded the Allen Institute for Brain Science to help build that foundation for all. He formed us to accelerate understanding of how the human brain works in health and in disease. From day one, we've operated in interdisciplinary teams at an industrial scale, generating tools, data, and knowledge that are freely accessible to all. In fact, Tom was on our site, I think, last night. Paul formed us to do basic research. We have some 280 scientists and staff here in Seattle, and a 2015 operating budget of $68 million that will approach some $100 million by 2021. And while we have collaborators all over the world, it's important to note that we are not a foundation. We actually do the lion's share of our work, I'd say all of our work really, in Seattle, in over 80,000 square feet of lab facilities. And while we started as a project that would have a beginning, a middle, and an end, a project 11 plus years ago, in 2012, Mr. Allen committed $300 million for the first 4 years of a 10-year strategic plan to address some of the biggest questions in neuroscience. Combined with the $200 million that Mr. Allen had already contributed, the 2012 commitment of $300 million brought us to a $500 million commitment to brain science. Know that we are humbled by this amazing level of philanthropy, and know that we aim to tackle big challenges that are worthy of this extraordinary financial commitment that Mr. Allen has made to the Institute. Before creating the Allen Institute, Mr. Allen gathered industry luminaries to lay out the challenges in neuroscience, shown here. They shared how Paul could contribute to the field, where he could have impact and where he could have leverage. This was in about 2003. The technology of the times, keep in mind that the Human Genome Project was just finishing, the imaging capabilities of that time, processing capabilities, before the words big data, and simple need pushed the group to the challenge of mapping gene expression in the brain. It was success in that initial project, called the Allen Mouse Brain Atlas, that led to additional projects and ultimately our current studies. Also, from the beginning, we had a unique operating model, drawing from the features of both corporate and academic worlds: scientific oversight, peer review, and feedback in the form of an active and engaged scientific advisory board. Moreover, we have project advisory councils that convene twice a year to weigh in on our scientific progress and our scientific plans for each of our major projects. And from the corporate world, we are milestone-driven and deliverables-based. And while we're a not-for-profit, we're also a not-for-loss. Our budgets are detailed, and every dollar is committed and fits within a 10-year plan, within the 10-year plan that was approved in March of 2012. And as we're an independent, not-for-profit corporation, you'll have to appreciate that we have a corporate board with expertise in the areas of science, biotechnology, company operations, law, leadership, and governance. Though ultimately, our secret sauce is teamwork. We believe that we will go faster and farther together, that scientific successes must be measured by groups rather than individuals, and team success is institute success. We define ourselves as a product organization. Our products are tools, data, and knowledge. We share our data on brainmap.org, and we track usage over time. As you can imagine, it's Paul Allen's Institute, to monitor and count our impact. To date, we have surpassed 5 million cumulative visits to the Allen Brain Atlas resources, with visitors from 6 continents and over 100 countries. These resources are all free and open to anyone around the world. As for tools, our transgenic mouse lines are exceptionally popular in the neuroscience field. In fact, we have developed 3 of the top 10 best-selling Jackson Labs mouse breeding lines. And in addition to our institute-funded atlases, we have partnered with the NIH, Swedish Hospital right here in Seattle, and various government agencies, all to extend the impact of our work. Our 10-year plan is to understand, to unlock the neural code, how activity in the brain's cortex leads to perception, decision-making, and ultimately action. To accomplish this plan, the Allen Institute has created a set of large-scale programs to understand the fundamentals from 3 interrelated dimensions shown here on the slides: components, computation, and cognition. I'm going to start with the easiest first. Our work in components strives to answer what are the fundamental characteristics of cell types, synapses, and circuits, and how is neuronal activity, such as sensory input, transformed in the brain by these components. Understanding the fundamental components of the brain is vital to our mission to understand the brain, both in health and in disease. So as part of this pursuit, we will create, and most importantly, we will share a comprehensive database of the cell types in the brain. All of our component data that we generate, all of it, will be presented within a common coordinate framework system. This enables neuroscientists around the globe to compare our data modalities and cross-reference our data with theirs, and vice versa. Nothing like this exists in neuroscience today. Our computation study, so it's getting a little harder now, a bit more work for our team and much more challenging, it'll take a while, they're aimed at questions of how is information from the world transformed by the code by cells in the brain, and what computations are performed by these codes, and then what are the step-by-step operations as we just pick this apart and go deeper and deeper. What are the biophysical mechanisms involved? In order to understand these critical components, we are building scalable platforms to record spiking activity of populations of neurons in both behaving animals and in cell culture models. Nothing like this exists in the neuroscience field today either. And finally, our studies of cognition are at the most abstract level. What we want to do is characterize high-level input-output behavior and investigate what types of sensory input lead to what types of actions. Sunday afternoon, I've thought about this a lot as to what was going on in this regard, the cognition. We aim to create predictive models, as I'm sure they would have liked to as well, of cortical behavior, allowing us to simulate brain behavior, test those models, generate hypotheses about cognition. And ultimately, well, again, nothing like this exists today in neuroscience. So our work is cut out for us. In the meantime, though, how do we get there? In the meantime, we have deliverables. So nerding out for just a moment, our near-term cell types and lineage deliverables include, in the mouse, production in our in vitro single-cell characterization pipeline. Operative word there, pipeline. We're doing it at scale. And protocols to couple our electrophysiological capabilities with our transcriptomic profiling in the same neuron, cross-referencing our work. Two different sets of scientists. We'll learn a lot. And in human, proof of concept for transcriptomic, structural, and functional analysis of single human cortical neurons. And in our in vitro human cell types arena, our lineage deliverables include maps to determine how progenitor cells give rise to different kinds of cells, how the brain forms. One more slide on this. Our near-term modeling and observatory deliverables include machine learning approaches for the classification of cell types and cell type morphology, so we're automating this science. Theoretical approaches to neural computation, software product design definitions for our cortical activity map data collection, and finally, an informatics pipeline, again at scale, for the calcium imaging data that we'll be generating. So yes, after some 10 years, we're doing big data. We aim to tackle these big challenges with 3 guiding principles. Team science, while we know we would operate faster following an academic principal investigator model, we do aim to go farther. So we've created multidisciplinary teams to tackle the deliverables across these dimensions: components, computation, and cognition. Big science. We aim to solve big scientific questions. So we'll go big, gathering hundreds of scientists and researchers to staff multiple projects, investing millions of dollars, all in a soon-to-be-completed, state-of-the-art headquarters facility. And perhaps our most important guiding principle, open science. We believe to have the biggest impact, all of our tools, data, and knowledge must be publicly available and shared widely. When we launched our 10-year plan in 2012, some 3 years ago, with 160 employees, we knew we were going to grow to more than 500 employees in Seattle. We broke ground in 2013 on a 270,000 square foot facility, shown here, in South Lake Union, where Westlake intersects. Oh, where did we go? Boy, looks like we're gone. Yeah, let's see what happens now. Well, I'll just continue on. Picture the corner of Westlake and Mercer. 270,000 feet, 6 stories. Each of the 4 labs, there's 4. Oh, here we go. Let's see how we do. Oh boy. One more. And there we go. So we plan to move into our new office space at the corner of Mercer and Westlake at the end of this year and be in full operation in 2016. So the Allen Institute for Brain Science will be sharing this space in its new headquarters with the Allen Institute for Cell Science, a new separate scientific initiative that will serve as a catalyzing force for cell biologists across the world. Announced this past December at a plenary session of the American Society for Cell Biology, the Allen Institute for Cell Science seeks to integrate diverse technologies and approaches at a large scale to study the cell as an integrated system. That is something that traditional academic labs cannot do. Paul Allen launched the Allen Institute for Cell Science, also at scale, with a $100 million commitment and a 5-year strategic plan. The inaugural project, the Allen Cell Observatory, will produce never-before-constructed visual, dynamic, and predictive models of the cell. This work will accelerate cell biology and biomedical research, since every disease relates to the behavior of specific kinds of cells in the body. Understanding the fundamentals of cell behavior and gaining insight into how defective behaviors arise is crucial to fighting disease in a meaningful way. Ultimately, we hope to have the same success in cell science as we've had over these past 11 plus years in brain science. We are pivotal players in the world's foremost efforts to study brain at the large scale. We're proud to be partners and actually founding partners of Brain 2025, which is the White House's technology initiative to accelerate the development and application of new technologies to enable researchers to show how individual brain cells and complex neural circuits interact. This effort started with some $40 million for the whole United States of America, $40 million from the NIH for the 2014-2015 year, and may multiply, when we hope it does, multiply many-fold over the 12-year horizon of Brain 2025. And we're also formal partners of the Europeans' version of this called the Human Brain Project, which is a 10-year, 500 million euro initiative, which will be matched by industry, so it's €1 billion, with goals that are complementary to ours. Mapping brain diseases, performing targeted mapping of the mouse and human brain, simulating the human brain, lots of computer power there, and developing brain-inspired computing technologies. Also, our leaders have chaired councils on the brain, including the World Economic Forum, or including at the World Economic Forum. Our CEO is chairing a panel there right now. And we've presented on the Presidential Commission for the Study of Bioethical Issues, and we create new conferences and new symposia to help fill the gaps in this burgeoning field. Together, we and our Human Brain Project colleagues and our Brain 2025 colleagues and neuroscientists all over the world have our work cut out for us. And we see great opportunities in that. Opportunities to practice open science, the data, tools, and knowledge that all of us develop will be much more impactful when we share. The resources, while great, will extend further when there's less redundancy. We also see opportunities to be collaborative. Ideas are more powerful when they're shared, and collaborations lever strengths and bridge weaknesses. We also see opportunities for focus and scale. We believe that our real-time success will come faster and have more impact with fewer projects at scale. And ultimately, we see opportunity as we accomplish the mission of accelerating understanding of the human brain in health and disease. And before I finish, I wish to thank the founders of the Allen Institute, Paul G. Allen and Jody Allen, for their vision, encouragement, and support. And I wish to thank our team, which you would see on the slides. There's some 200 of them in the picture, and there's 280 of us showing up to work every day. They're the ones that are bringing alive our 10-year plan. And thank you for your interest in the Allen Institute. First question?
I just read a book called The Swallows, and the author makes 2 points. One is that the brain is plastic and can be changed through practice. And the second is that the advent of internet taking over everything, where things flicker in front of our eyes and change every 5 minutes, is training our brain to be more superficial, less deeply thoughtful. Would you make a comment on your view of that?
It's 20 for us. So I'm a business person. So we do have programs at the Institute that are called plasticity, and it is definitely a tip of the hat to a number of theories around how the brain changes as we get older. I can't speak to those from a scientific perspective, but from an operations and human perspective, I'm very hopeful.
Thanks for joining us today. Elon Musk, the head of Tesla, has recently come out stating concerns about artificial intelligence, sort of the other end of the spectrum. But has the Institute or Paul Allen commented on this concept of whether or not from an AI perspective that's part of what you're looking at, or are you simply and obviously looking at all the complexity from a human perspective? Thanks.
So we are doing basic scientific research. Paul has staked a claim to that topic, and it's covered pretty well in the press. I'd refer you there. We are doing basic research, and we focus very, very closely on that.
David, before we get to John's question, David, back here, I have a quick question. You probably don't want to answer this verbally because you don't want to be quoted, so just shake your head. Did the Allen Institute have anything to do with the intelligence level of the Legion of Boom?
Okay. John. We'd love to take credit for that.
Perfect segue, because I have seen recent stories in the media about various efforts to understand and isolate the parts of the brain involved in religious experience. I wonder if the Allen Institute is that on your agenda to any extent, and in relation to Bob's question I was going to ask, was there an especially high significance of that during overtime last Sunday?
Our chief scientific officer writes on consciousness. He's not here today. There's so little known about the brain from the standpoint of basics, cell types. We don't know how many cell types are in the brain. We don't even have a way of organizing them. We haven't decided whether it's the synapses or the cells or the neurons, or whether we should focus on the calcium that's in our brains, or if we should focus on the electrical aspects of our brain. There's so many basic things. Someday, hopefully during Christoph's life, because he very much would like to tackle these bigger topics, but we're doing basic science, very basic.
This may now be a moot point, but I was wondering, it sounds like you're looking at genetic basics. Are you also including accidents? So many of our soldiers are coming back with brain injuries. It's one of the biggest injuries. Are you also looking at the difference in the mapping of the brain once an accident has happened that wasn't genetic?
We've done a bit of work on that. Paul made a donation to the University of Washington a little over a year ago, and the university is collaborating with us to do some work in that area. It's very early, though, and it's just to take advantage of some of the scale work that we've done over the years. Very early, though.
David, Carla has a question.
David, it's exciting to hear about the Allen Institute's move towards more open science and just the collaborative viewpoint that you see going forward. Certainly, you can imagine that there are other, be it organizations or businesses that may not be as collaborative in terms of using all the data and the things that you produce. I just wanted to know, as we move towards open science, what are your biggest hopes and fears in really having this all open and accessible to anyone who wants it?
Well, open science to us means that what we find can be shared as a platform for everybody. Now, Paul wants to have the biggest possible impact that he can, and in order for that to take place, we were practicing open science. So our scientists, when they join us, are signing on to being co-writers of articles and using the same data when it's available to the rest of the world before they write papers. We share everything as we find it. So we do make sure that we have licenses to the materials that we bring in. And that's probably one of our biggest challenges of open science, is to make sure that what we put out there respects everyone else's intellectual property. And we take that very, very seriously. So we have a legal department that makes sure that we're respecting everyone's IP. And when we're in conversations with folks about that, they know that it will be open. And we're able to do what we do as you look at our atlases and our resources that we'll have.
You mentioned that all of this is being done as a not for loss. Does that suggest that all of the work has potential commercial application that can benefit the Allen Foundation, or is this purely philanthropic?
It is purely philanthropic. When I say we're a not for loss, it means that we have to adhere to our budgets. I am here to make sure that takes place.
David, over on your left, Paul has a question.
Hi, David. Thanks very much. So it's been determined there's certain conditions, such as autism, where people have a genetic predisposition to the condition. What's not been determined what the triggers might be. A lot of people suspect that it's environmental. Is part of your agenda to start looking at environmental impacts on whether it happens to be Parkinson's, autism, ALS, etc.? Is that something on the agenda for you guys?
It could be downstream, but during this 10-year plan, what I described is all we can take on, which is a lot.
Thank you, Mr. President. I sort of look at Rotary like a great big curriculum opportunity. And 2 weeks ago, we had a wonderful presentation on race relations, and maybe some of that motivation came out of Missouri. And I was just wondering, one of the issues in Missouri is poverty. And since it has been said that 10% of the population control 90% of the wealth, and 90% split up the other 10%, is your brain study going to in any way help what could be perceived by some as an imbalance in the distribution of funds?
We do basic science.
David, off to your left. Grace has a question.
I'm going to ask a business question, or what I think is a business question. I think it's really interesting that you're really in a groundbreaking type of field. And just as Microsoft started out in a little garage, I'm curious what you think is the economic potential of citing this, quote, nonprofit, but really as an industry in this community, and the potential for attracting other growth and expertise to this area.
Well, we'd love to catalyze business in Seattle. I think we have a real blessing that Paul chose, of all the places that he could have done this, that he chose to do it here. And we hope that the platforms that we're creating that are freely open to everybody will cause other folks, hopefully folks here in the Seattle area, to take that data and add something to it that adds value, that creates some intellectual property, and form companies with it. But this is a philanthropic effort. I want to be very, very clear. This is a gift that Paul has made to the Institute, to the community, to brain science, to how we understand ourselves as humans, ultimately.
That's actually a perfect segue to what I'm going to ask you. I run Keiretsu Forum, which is an angel investor group. Just think Shark Tank, but we're not that mean. So we see, this year alone, I've seen 4 companies from around the world that are working on Alzheimer's, Parkinson's, different diseases that affect the brain, or they feel are in the brain. Could they get access to your data? Would there be some way for us to contact you with these new technologies that are being funded? Because it kind of seems silly that we're doing it on this end, on the private equity side, when you're doing a philanthropic piece that might match those companies together.
All of our data is actually on our website. Truly, everything is accessible and open, and that's our way of sharing. And these mouse lines that we created are another example of the kind of thing we hope to develop in the future. Yes? Maybe someday. Again, we have our plates are really full. Okay, I guess last question.
Susan has a question.
Thanks, David. I wanted to pick up on the curriculum question, because my experience with the Allen Brain Institute is that you do have a marvelous education outreach team that brings young students, middle school students and high school students in to realize there are so many potential opportunities for them in the world of research. Could you talk about that? Because yes, you are very basic science, but you also have some amazing exchanges for young people.
We've had a handful over the years. We've got a nice history of working with the University of Washington, with the Pacific Science Center. It is a nights and weekends kind of thing, though, for our scientists to help this way. And I'm proud of what we're able to do, though our day-to-day is basic science.
Okay. Let's have a big hand for David. Before I took this job, I was told you can always tell the quality of a program by the number of questions. We had more questions than we had time for, so thank you so much, David, for being with us today. Another big hand for David Poston.
Seattle Rotary Online is made possible in part by a grant from First Choice Health, working with the Washington Health Information Collaborative to use technology to bring better health care to patients throughout the Pacific Northwest. First Choice Health.